Hi, good morning, and welcome to the ZP Developer Zone. There was a little bit of clicking around there because I wanted to make sure that I was on the best internet that I possibly could be for this. So every Thursday at 8 a.m. London time, we like to give a live streaming, let's say demonstration, or not live streaming, but a live webinar to the members of our ZP Developer Zone. So I'll just jump essentially straight into it. Okay, so jumping into it, we have our ZP Academy. If you're unsure about electrochemistry or electrochemical biosensors, there's a couple of free courses on the ZP Academy, so please sign up for those free courses. Obviously, we have this webinar every week. It's fair to say, that obviously at ZP, we do provide biosensors, screen printed electrodes, electronics, and we support them through the webinar every week. I just want to say good morning to Hitcham, who's just come online. And Hitcham, we will discuss your emails pretty soon. The next thing we need to discuss is collaborations. We are trying to organize some collaborations with our members of our ZP Developer Zone. We do offer jobs. We have our ZP Developer Zone website. This is really for sort of developers and academics who want to learn about biosensing, and we have that website. And I just want to say hi to Hassan as well, also this morning. And also, it's probably worth mentioning that we also do workshops. I'm going to talk very quickly today, because the reason I want to talk very quickly, I want to say hi to Aftab as well, who's also come online this morning. The reason I'm talking very quickly is because we've got a lot to get through this morning, and I have a hard stop as well. It's on the workshop front. It's probably just saying we're just trying to finalize. It's a bit of a scramble, but we're trying to finalize that actually we will be probably demonstrating at an e-conference. It's based at Madurai Kamaraj here, as you can probably see. Some details will come through shortly, so probably worth following us on LinkedIn or Facebook. But we will try and get some details out soon. But I think we will be doing some live demonstrations at this conference. We have been invited. And the reason I mention it so quickly is because it's actually next week, so there's not much time to kind of warn people about that, but we will be. Questions. We had some questions through. Some of the questions were, what of our screen printed electrodes are suitable for redox reactions? I'll discuss that. Another very interesting question that we had through was glassy carbon electrodes versus screen printed electrodes. And what should people's expectations be? Will they give the same results or different results? And we'll discuss that. Heavy metal detection on screen printed electrodes. I'll be able to show you some data that we've actually gathered this week, so you'll be able to get some good reassurance there. This is an interesting one. Question 4 was about using screen printed electrodes as electrodes in HPLC, electrochemical detectors, ECDs, and that's something I've been thinking about or touching upon for over 10 years. Also doing biosensing in body or on body, looking at pH, chloride and glucose, and we'll discuss that. Looking at vapor phase chloride measurements, we'll also touch upon that as well. And then lastly, electronics for ketone sensors. So if you recognize your questions there, great. And if you're watching online later on and you're watching the recording, then you'll find, if you jump around the video, you should find the answer to one of your questions. So question number 1, we are developing electrochemical sensors for use with a variety of biomarkers using redox reactions. Great. So I just want to say the thing about Zimmer and Peacock that makes us unusual when we're giving you, let's say, our advice and our opinion is we really are an unusual company that actually we make all of these biosensors. They're all on our website, from glucose through to purine here. And we also make screen printed electrodes, and we actually use our screen printed electrodes to make our biosensors. So whenever people are asking us, about either screen printed electrodes or biosensing, the proof of whether our screen printed electrodes work as biosensors is in our product lines. You can clearly see it. So people were asking for some advice around the electrodes for different types of biosensors. And so I would say, if you're looking at a glucose sensor, then I will show you in a bit the right platinum electrodes. If it's oxygen, you need the platinum electrodes. If it's lactate, you need the platinum electrodes. If it's hydrogen peroxide, you need the platinum electrodes. If it's pH, you'll need a carbon electrode. If it's chloride, you'll need a carbon electrode. If it's potassium, you'll need the carbon electrode. If it's calcium, you need the carbon electrode. If it's alcohol, you'll need the platinum electrode. If it's nitrate, it's the carbon. Ammonium is the carbon. Uric acid is the platinum. Sodium is the carbon. Phosphate is the carbon. Sulfite is the platinum. Redox is the platinum. Ketones is the carbon. Conductivity can actually be gold, platinum, or carbon. NADH is carbon. Fructose is platinum. Cortisol is platinum. And purine is carbon. So I'm just going to give you a sense that really, we do use mostly carbon and platinum in our biosensing, and sometimes we use gold. Now, what electrodes, if you're starting in biosensing, what electrodes are going to recommend? I'm going to recommend our platinum value electrodes. We use them a lot. They work. They're great. It makes life a little bit easier. I also want to just say hi to Hasim, who's also online as well. Hasim has been, I would almost say, the founding member of the ZP Developer Zone. So nice to see you this morning, Hasim. So I would definitely recommend the platinum electrode from ZP. All these links, by the way, are going to be underneath the video when we finish. So if you want to do redox reactions and you're trying to do biosensing, then I would suggest this platinum electrode. On occasions, especially if you're doing immunosensors, this gold electrode, it's the value gold electrode. And now this is the sort of resistance, or the pièce de resistance is this carbon electrode. We use this a lot, for example, in our pH sensors. It's our top selling electrode, it's our lowest cost electrode, and it's really, because of the volumes we sell, it's probably one of the best ones we've got. And this is our hyper value screen printed electrode, and you'll see this hyper value screen printed electrode pop up a lot today in several of the answers to the questions. So if you're trying to do redox reactions on screen printed electrodes, these 3 links, I would focus in on the platinum and the carbon, and the 3 links will be underneath the video below, or underneath the video. In terms of connectors, it's one thing to get hold of the screen printed electrodes. You will need some connectors. So I've got a link here to the connectors, and there's 2 types of connector there. One for a 10mm width electrode and one for a 7mm width electrode, and you will definitely need the 7mm width electrode. So I hope that helps with the question about, what electrodes should I be getting for my redox reactions. The platinum and the carbon, and on the carbon I specifically suggest the hypervalue carbon electrodes. Question number 2. This one is a very intriguing question. The inquirer is actually interested in lipopolysaccharides, which I think is linked to endotoxins. So endotoxins, again, something I've been working on, or started looking at about 10 years ago. This is a good question, because I basically say, look, I did my R&D on glassy carbon electrodes, and now when I translate over to SPEs, the good news is it actually works. There's a quick question here which is, what's the average shelf life of an SPE? It's a good question. Platinum and I think carbon has the highest shelf life. Carbon is really quite inert. Platinum, if you leave platinum on the shelf, it can slowly tarnish, and if you leave gold on the shelf, it will slowly tarnish. So they've all got excellent shelf lives. We don't clean carbon electrodes before we use them because they're quite inert. Gold electrodes, we do clean them before we use them. Even the screen printed ones, it's not, so they haven't got a poor shelf life. You might just need to, that gold can tarnish with time, and you might need to make it shiny gold again. Platinum, we don't tend to need to clean it so much, but for repeatability you probably would. Now this inquirer is actually using carbon, so what's the shelf life of carbon electrodes? I'm not entirely certain, but I would say a long time would be my quick answer on that. One of the questions in this inquiry is quite interesting, because when you're doing lab experiments, you could allow your glassy carbon electrode to reach some kind of equilibrium before you do the experiment. But of course, when you're trying to translate that science into a in vitro diagnostic, the patient, the doctor, the nurse is not going to wait 20 minutes while you while your electrode equilibrates. Essentially, you can't wait for the equilibration time. You have to put the sample on, grab the data, and and you're done. You want to be doing that within kind of 2 minutes, before the patient gets bored and wanders off. That means sometimes you can have both signal generation and equilibration going on at the same time. So glucose sensors, I would suggest that when the sample first goes onto that carbon-based glucose sensor, it is equilibrating, but as long as the signal is also strong, the strength of the signal plus the error from equilibration, the strength of the signal is strong enough that actually it doesn't matter that you might have some equilibration going on. And as long as the equilibration is reproducible, it doesn't matter if electrodes are undergoing reproducibility or undergoing equilibration. So I'm glad that it works. All that matters when you're trying to do medical diagnostic development is that it works. Whether the data looks as beautiful as your lab data doesn't matter as long as it's reproducible. So for me, it sounds like you're doing the right thing and your instincts are correct. And thank you for sending the photo, because it does tell me that you're on a carbon electrode. My sincere suggestion is grab a bunch of these. This is the ZP Hypervalue electrodes. Their cost versus what you're using means you can essentially afford to make more mistakes and do more experiments before you burn up the R&D budget. And it's probably worth saying that AFTAB is online this morning. AFTAB in India has these products up on the government marketplace through his company Technando. So question number 2, you're really just looking for a reassurance. I think you're doing the right thing. I'd suggest, obviously, I'm biased, but our hypervalue carbon electrodes, we use them all the time. What's unusual about Zimmer and Peacock is the biggest consumer of Zimmer and Peacock screen printed carbon electrodes is Zimmer and Peacock. And that's what makes the quality so high, because we need to use them ourselves. Question number 3, I am talking fast this morning, is because question number 3 was really about anodic stripping voltammetry and its use for basically pollution or heavy metal detection. And I noticed people like Hasima online, and I know you're kind of interested sometimes, Hasima, in things like environmental testing. I know you're sometimes more interested in sort of veterinary, but environmental sometimes comes in there as well. And this is let me sort of jump into the question: can we use screen printed electrodes for doing heavy metal detection? The quick answer is yes, you can. You will need to use a profile, a technique called anodic stripping voltammetry. In anodic stripping voltammetry, you have a kind of voltage of maybe about 0.5 volts for the cleaning step, the electroplating step, which might be around about negative 1 volt, your equilibrium step, just keep it at the same voltage, and then your actual stripping when you go from the cathodic potential of, like, let's say minus 1.1 up to about 0.5 volts. I've looked at the software that you're using. I think you might have to use the scripting part of the software in order to have all those steps automated. There were sort of 4 steps there. There was the cleaning, there was the plating, there was the equilibrium, and then there was the linear sweep voltammetry as well. So I think you might have to actually program that in to your software. Again, I'm sorry I'm talking so fast this morning. The electrodes I'm going to recommend are our gold electrodes. Gold, because gold has traditionally been used, I think, in doing this anodic sweep voltammetry and detection of heavy metals. But also, try again our hypervalue carbon electrodes. You will also need a connector. It's the same 7mm connector that I suggested earlier on. And your Potentiostat has 3mm pins, and those will just plug in the back here. It's probably worth saying that when I make these recommendations, this is some data that we got this week. This is detecting some heavy metals using anodic sweep voltammetry, and we did it on our hypervalue carbon electrodes. So what can I say there? I can say that my recommendation is based on data we actually do in the lab. Because the inquiry was actually coming from a commercial company, it's probably worth me saying that to do solid assay development and really make the science solid and repeatable, it takes quite a big team. I mean, at Zimmer Pigott, we do have that team. And when we're doing this kind of work, we're not on a single channel potentiostat. We might have 5 scientists on multi-channel potentiostats doing, gathering up all that data, because, it can take a long time to do it one at a time on a single channel potentiostat with a single scientist. And this is one of our scientists in our lab. This is the way we work. We have rigs where we, can test multiple electrodes at the same time, and we wouldn't have just necessarily one scientist doing it either. It's probably also worth saying that we also have, there's a free database online called Julie where we upload all our data and do all our data analysis, because it's really an industrial effort to do proper, let's say, development and then commercialization in the commercial region. And we do that as a contract development, contract manufacturing. Again, sorry for talking so fast. This is a really interesting question for me, because I have been interested in the use of screen printed electrodes in organic solvents and in HPLC for quite a long time. I was using HPLC well before I was actually an electrochemist. So, obviously with HPLC, you have a lot of organic solvents that kind of get pumped through columns. And then, this is not from my website, this is Antec, they have an electrochemical detector. And I've always thought that actually you could make these electrochemical detectors much more efficiently, low cost, by using screen printed electrodes. So let me make a recommendation on the electrodes I think you should use. You need an electrode that's obviously resistant to organic solvents. This was an image I made probably about 4 years ago, where I went to see a client, and essentially they were showing me one of our competitors' electrodes, and they were not at all resistant to organic solvents. And so we did go around and develop a range of carbon, platinum, and gold electrodes. The thing about making organic solvent resistant electrodes is it's such a niche part of the market that it's really hard to kind of support it. Most people with screen printed electrodes are trying to do biosensor type development, in aqueous or water-based systems. So it's a bit of a niche trying to make organic resistant electrodes. But we did make quite a few, and we also made some videos about it as well. And I do have that kind of material on one of the ZPE pages, and the link is below the video. My recommendation is kind of quite simple, really, that if you need a couple of electrodes to sort of prove out the idea, I would actually just go for this gold one here. The reason being is, of all of these electrodes, this is the one that we're making in the highest volume. I'm glad that you found that quite interesting, Hitchem. This is the one we make in the highest volume, and it also is the only one that we can actually sell in packs of 2. So unfortunately, we do have a lot of experience in this. When people need to dip their toe in the water and just go for small volume purchasing, then the only one we really have is this one, and we do packs of 2 on that. And as I say, there's quite a lot of material supporting that. Just one thing on the carbon electrodes, we do have these carbon electrodes which are also resistant to organic solvents. My only sometimes concern with them is that because the carbon is specifically formulated to be resistant to organic solvents, it ends up having quite a resistance along the track. So when you're trying to do beautiful cyclovoltammetry or something like that, it can end up distorting the signal, because it's like got a big resistor in series with your electrochemical experiment. If you're trying to use something like amperometry as the detection method, then I think this is less important. It will reduce your signal, but it won't so much distort your signal. But my recommendation is on the previous slide, which is get a couple of these and prove out your ideas on those. The other ones we make them, but we only sell them in higher volumes, which doesn't make them so interesting to academic groups. Question number 5. The inquirer is kind of interested in doing, let's say, physiological measurements of things like glucose and pH. They mentioned temperature here, and also calcium. So I'm really going to address the pH and calcium. We do have a low cost set of electronics that I'm going to recommend. It's €250. This one will do the calcium, and it will also do the pH, as I mentioned here. I'm going to recommend this pH set of sensors because we essentially can, we can make these sensors at the lowest cost. So if you're dipping your toe into doing biosensing, then I would recommend these particular pH sensors because you get 10 of them, for the price that we can normally do 2 of them. So I would recommend those particular ones, and I put a link to that as well. And then finally, I'll also link to this set of electronics as well. It's worth looking at this link because there's really quite a nice video by one of our engineers on using it to measure pH. So I think the reason I kind of recommend it is because the electronics are €250, the pH sensor is €100, so you can get going for much less than €500, which is, when you're first starting, you want to minimize the cost so you can learn quickly and not risk everything. This question number 6 is a tricky one. The person wants to measure chloride, and they want to measure it really in the kind of in the vapor phase. So the first thing I want to say is, this is kind of what our chloride sensors look like. In order to make a chloride measurement, we have to get the sample, the liquid sample, onto the sort of sensing end of these sensors. So it's here. The reason I mention that is you're in this sort of vapor phase and we need to be in the liquid phase. So you have to think to yourself, do I need to cool this electrode in order to sort of get the dew point and bring enough vapor bring it from the vapor phase to the liquid phase? I mean, we do things like that, but we do it on Peltier. You can actually use the same electronics that I was just referring to. The earlier inquirer was trying to measure chloride, in sort of human type applications. It was a €250 set of electronics. You can use the same electronics in this application as well. The big thing is we do use our sensors in these kind of harsh environments, but when we do it, we've got a really strong engineering group. What we've done here is we've 3D printed some boxes. We've put the electrodes into there, and we've really epoxied them in. We've really made it quite secure, because what's going to happen in the experiments or application that you're describing, it really sounds like the vapor is going to be everywhere, and it's going to get up inside the connectors and corrode the connectors, short the electrodes, and you get horrible signal. We do deal with that, but we put quite a lot of engineering in to actually prevent that. So you're really gonna have to think that through a bit. We've got the sensors, we've got the electronics, we have the know-how to do what we call potting. When we're trying to make our electrodes robust. We have a really good member of the ZP developer team called Ali, and I know he's quite interested in putting sensors into the environment, and he's going to have to go through all this, let's say, potting or protection as well of his sensors when he does that. Right, finally, ketone sensors. So we've got an inquirer who has some of our ketones. They're very interested in electronics. First thing, big disclaimers. At Zimmer & Peacock, I think we're one of the world's strongest analog electronic firms. We make a whole bunch of electronics for biosensing. I really recommend, you can find this on our website, the Sensit Smart Potentiostats. When you're first doing development, I think it's bad news to be developing electronics and an application in parallel, because when it's not working, you're not sure, is it my application that's my problem, or is it my electronics is my problem? So I do suggest that people actually start on an R&D set of electronics. You can find this electronics on our website. It's called the Sensit Smart. But we also have this kind of thumb drive electronics. So I've been mentioning a few times today a particular set of electronics for €250. We have that. It's almost thumb size. And then we don't sell this on our website, but we do have this set of electronics that's essentially the size of a fingernail. Now, the inquirer might be more interested in not so much engaging with our electronics, but actually doing it themselves. I don't completely recommend it from the start, but people want to do it. If you want to do it yourself, then I would Google the term LMP 9100, or I would Google the term Zimmer and Peacock LMP 9100, and then you'll find quite a comprehensive web page. I'll mention on the next page. This chip is from Texas Instruments. It's not one that we are actively doing our next generation development upon, but it has traditionally been used in the glucose world. When you look at the web pages that we have on it, it's sort of, these are our older web pages, and it reflects. So we don't currently use it, but if somebody wants to develop for themselves, then it is it's a decent enough chipset. It'll do the job. As I say, here's a link to it that will also be on the video afterwards. There's also you can get through to the relevant TI website from there as well. And if you look at the TI website, they do have a lot of information on their chip and how to use their chip. If you've got one of our ketone sensors, then we always have the counter working and reference electrode in the same place, both on our screen printed electrodes and also on our also on our biosensors. So there's the working electrode on the chip that needs to connect to the middle pin. There's the reference electrode that needs to connect to this right hand pin or pad, and then there's a counter electrode that needs to connect to the left hand pad. So I know a few of you have electronics backgrounds, and just FYI, that was how you'd wire our sensor to the Texas Instruments chip. It's also worth saying there's a lot of open source potentiostats out there. You've got the UWare, the CheapStat, the PSOC, the DStat. We've basically, we've linked to all of them off this particular. If you go Zimmer and Peacock free open source potentiostats, you'll find these. So that will also be a good resource for anyone who wants to do a sort of DIY, do-it-yourself set of electronics. Right, I had to go very quickly because I have to go to a meeting in 15 minutes, but I do appreciate I went through a lot this morning, so I'll just do a quick summary now. Electrodes for redox reactions. It's our value platinum electrodes, or it's our hypervalue our hypervalue carbon electrodes, or our value gold electrodes. They are linked underneath the video. The inquiry about the glassy carbon electrodes, it sounds like you're doing the right thing. That's right, Ahmet is online. There's a guy online, by the way, called Ahmet, who did he developed an open source potentiostat as part of his master's thesis. So I was thinking about you, Ahmet, and just want to kind of let everyone know about that. So the guy who's inquiring about glassy carbon versus screen printed electrodes, you're doing the right thing. I think it's worth reaching out to Technando about our screen printed electrodes, because then we can support you better. Heavy metal detection, you saw it yourself. Those hypervalue carbon electrodes will do the job, and you need the connector. HPLC, there was a particular gold electrode that I've highlighted, and I have put a link to that. Please start with that. That's the best option at low volume that we have for you at the moment. In body on body measurement, start off simple. Do the pH electrodes that I suggest and the board that I suggest. Build up complexity after that, but get those first experiments underneath your belt. The vapor phase chloride measurement, we have a chloride sensor, we have the electronics. Your biggest challenge in that application is protecting the electronics and protecting the connections from that vapor. We've done it ourselves for other applications, so it is doable. If you get stuck, then we maybe have to return to that question. Electronics for ketone sensors. ZP has a lot of experience in this. You're welcome to tap into that, but we do that as a contract development and contract manufacturing. Second question, second part of that was TI Instruments. Look at the LMP 9100. Third part of that is there are a whole bunch of open source potentiostats out there, and one of those, you could follow one of those as well. All right, I wanted to say, Hitcham, Hitcham just made the comment that we had a lot of good questions today, and he was also appreciative of the answers. To be honest with you, it is nice to get these questions, because otherwise, we're not talking about things that are real. these are all real questions and all real world applications, and I think that's what makes this forum, this webinar, and this so interesting, because we're trying to get sensors and electrodes into real world applications. We all love a bit of fundamental research, but it is nice to see all these people asking real world questions. So yeah, thanks very much, guys. I will sign off. I have to shut down the computer, put it in my bag, jump in a cab and go to a meeting. But thanks very much, and take care of yourselves, and I shall speak to you all, many of you who I can see online, Hicham, Ahmet, Aftab, we're often in correspondence, so it's nice to see you guys. All right, take care and have a good day, guys. Bye-bye.